So Python is a high-level programming language that has a wide variety of places where it's used. For example, professional software developers, we have scientific developers, casual programmers. Casual programmers, it's a very nice place to start learning programming because it's very simple and it's very intuitive. So for casual programmers, they like it, and especially Python has some very nice libraries that make your work very simple. So casual programmers like this, as well as beginner programmers. So simply put, Python is, this is a bit on the programming side. You don't have to take much note of this, but it's good to know what it means. So simply put, Python is, it's an object-oriented language. That's more of about, that's architecture. It's an interpreted language. It supports dynamic data types, independent from platforms. That's where we're able to run it. It doesn't specifically have to be just on Windows or on Mac X, so it's independent of platforms. Focused on development time. It's simple and easy grammar. It has high-level internal object data types, automatic memory management, and it's free. It's open source. So there's nothing much about Python. The first Python version was released in 1991 by that guy. I really don't know how to say that name. But yeah, so people have been working with Python since 1991. Roughly every year or so, they produce a new version. A new version is they've taken care of bugs, probably security. So every new version comes with something. However, when you're upgrading from one version to another, some things might change. So if you update your Python version or your Anaconda version, it's interesting. Okay, it's a rule of thumb. It's better to go probably online, check the documentation about the new version they've released, so that you're able to see if there's any changes that they've made. For example, I'm going to show you one example as we're doing this for Faustin. Faustin, hi. Faustin. Okay. So can you guys hear me?
Yes.
Okay. So characteristics of Python. Again, this is just almost the same as what Python is. That's not really much that you would need. Language properties, also not too much. This is where it becomes interesting, what we're going to be working with. So the scientific stack, a major feature of Python as an ecosystem is the availability of a large number of libraries and tools. So libraries are basically the pieces of code that have already been programmed to do something specific for you. So your work is to understand how that library works and what it can do for you. So there's a certain set of libraries that is collectively labeled the scientific stack. These libraries are, and these are the things that you're going to be learning in class. So actually the next lesson that you're going to start with is this first one, NumPy. So NumPy in full is numerical Python. Numerical Python, this library allows you to perform aggregate functions on your data. So this is definitely going to be a library you want to be good at. So NumPy provides a multidimensional array object to store homogeneous or heterogeneous data. Okay, basically numerical Python, all it does, it helps you to perform aggregate functions on your data. SciPy is scientific Python. So scientific Python is almost like a scientific calculator. It helps you to perform more complex things as opposed to NumPy. Matplotlib, this is visualization. Visualization is very important in telling a story. You might have a very huge data set, and looking at each data point individually might not be able to tell you a story. You might not get what you're trying to get from it. But with visualization, you might be able to see trends, clusters, groupings. So visualization is very important when you're working with data, especially large sets of data. So Matplotlib allows you to do plotting and visualization, and there are a couple of libraries that are built on it. Matplotlib is from a while back. So as time goes by, they try to make things easier. So from Matplotlib, we're going to look into something called Seaborn that is built on Matplotlib. And there's after our Seaborn, there's PyPlot, which is there's Plotly, there's Plotly and Plotly Express, but we're going to see that later. We have PyTables and we have Pandas. Pandas is also very, very, very important. This is what we learn in week 3. Pandas is built on NumPy, so you have to understand NumPy for you to understand Pandas. However, all these things are based on Python, and that's why we're having this first introduction class. You first need to understand the very basics of how Python works so that you're able to understand these libraries. And that is the lesson we're going to go through today. So you can see the libraries, NumPy, SciPy, Pandas, scikit-learn. Scikit-learn is what we're going to use when we get to machine learning. So with machine learning, you're able to learn from your data and you're able to predict from your data. So machine learning is where you're going to encounter scikit-learn. Your visualization libraries, as you said, there's Matplotlib, there's Seaborn, there's Plotly and Plotly Express, but you're going to see those later as well. So the rest is just going through the individual libraries. This is not really important. We can go straight to it so that we have all the time that we need to. Okay. So sorry, I have a couple of things downloaded on here, but yeah. So I will create a new notebook. This is the one we're supposed to have by the end of this class, but I do not want to start here. So you guys remember how to create a folder from last week? You were taught by Timothy. However, we can still redo it again. So I would like you guys to create a folder so that all your work is in the same place. You won't have trouble finding your folders, your work. So if you don't have a lot of things, it's going to be labeled untitled folder because it hasn't been named yet. You can tick on it and then rename it. So you guys are cohort 10. I'll name this cohort 10. And then within that folder, we can now create, sorry, not a text file. We can now create a Python file. For you guys, you should be using Python 3. So this is our blank notebook where we're going to start. You can rename your notebook you can either rename your notebook from here, or you can come to File and rename it. However, I prefer doing it from here. It's a lot simpler. So I'll call this Introduction to Python. File. If you come to File, you can open a new notebook. You can open a notebook that is already existing. You can make a copy of the notebook that you're currently on. For instance, make a copy of this Introduction to Python notebook. Save as. This is to keep saving your work so that you, in case anything, okay, it auto saves, but in the event that something happens, maybe your internet or power just goes off, it's good to occasionally keep saving. You can rename your notebook. You can save and checkpoint. Saving and checkpoint, this is you save what you've already done, and then you create a checkpoint such that if anything goes wrong, for example, a certain cell, the code is not running, or it's just giving you an error, you revert back to the last time that you saved your work. This is like a restore point for Windows. So that if your code is not running or it's having an error, you can just go back to the last time that you saved your code and it was working correctly. So revert to checkpoint is to go back to that checkpoint that you created to the last time you were aware that your code was running correctly. Download as, this is where you would come to download your notebook in the event maybe you want to send it to someone or what have you. And we mostly download them as notebook with the extension IPYNB. The rest of these are not so important. You will hardly, if ever, come across them. So you're mostly going to be working with Notebook and Python. And this also Python, the .py extension is very rare. So Notebook IPYNB is where you would come to download your stuff. And then close and halt is exactly that, to close everything. Edit, basically undo and do things, just the usual. View, nothing much. Insert, you can insert a cell above the cell that you're currently in or the cell below. Cell, this is, you can run your cells from here, but I'm going to show you keyboard shortcuts so that it's a bit easier. So this is the operating system, quote unquote, I would say, that is running on your, for your notebook to be running. So you can either interrupt it. This is probably when maybe you created a function that has maybe an infinite loop, meaning that your laptop is most likely going to crash, because that means there's something that is always running in the background. So in the event that something of the sort happens, you can interrupt your canal. It's going to immediately stop the codes from running. You can restart the canal. It's going to restart everything, but it's also going to clear everything that you have run. So don't just go about restarting your canal. You can restart and clear output. This is going to make some sense after we've seen some cells being run. Restart and run all. This is most likely after you've created your whole notebook. Probably you've created it in sections, and then now you'd want to see how it runs as a whole. This is what you use, restart and run all. Reconnect, this happens when probably the connection has gone down, internet or localhost, something is wrong. So you can reconnect and just get back to where you are, or you can shut down. Widgets, not anything too important. Here, the most important thing, or rather, if you're not a big fan of moving around your cursor a lot like I do, for those of us who program, it's a whole lot easier to use keyboard shortcuts as opposed to keeping on moving your cursor across your screen all the time. So in your free time, you can come to help and keyboard shortcuts. This keyboard shortcuts make your work so much easier. However, you will get used to them with time, so don't feel pressure to learn everything. I'm going to show you a few that are what we're going to need, but in your free time, I would really advise you to go through keyboard shortcuts. So this icon is a save and checkpoint. So it saves where you are right now and creates a checkpoint. In the event that something goes wrong with the code, you can go back to the last time that your code was running correctly. This just inserts a cell, as you can see. This cuts the selected cell. A selected cell is the one that has a blue border around it. However, if you're inside the cell, you can see it turns green, and this is not a selected cell because we're now doing things inside the cell. However, for it to be selected, it has to turn blue. So if we come to cut selected cells, we are cutting the cell that has the blue border, so that will do that. Copy selected cells, that's copy the cell that has the blue border, paste. This is move the selected cell up or down. So this will make a bit more sense when we have a few more cells. Run, this is going to be very important. This is what we're going to be clicking on after you've written your code and you now want to see the output of the code. This is what we're going to use. This is basically this stop. I'm sure we've grown up with tapes and whatnot, so this is stop, interrupt the canal, exactly. This is to restart the canal, and this is to restart the canal and run everything. So this is, as we're saying, you've probably created your notebook in sections and you now want to see the output for the entire notebook. Now, here is another very important place because you might run into some errors in the event that you don't get this. So this drop down are the types of cells that you can have on your Jupyter notebook. By default, they're code. As you can see, this cell is code. By default, they're code because we are coding in this environment. However, I might probably want to make some notes within my notebook. Maybe you're making a presentation or even just for yourself. You've maybe done some research on something. Maybe you need to just jot down something somewhere. You're going to have to use some a different format from the code so that the canal is able to interpret and understand that this is not code to be ran. It does not require output. It's just there to be displayed. So by default, all our cells are in code. However, we can change them to Markdown. So with Markdown, as you can see, there was something that was with code. There is this in, and it's going to give you a cell number. You're going to see this after we run some few cells. So code has this in, but if you change to Markdown, you can already see there's a bit of a difference. So Markdown is used to just jot down it's just used to jot down some notes in your notebook. For instance, I can say that the first thing we're going to learn is data types. Or rather, let me just title it Introduction to Python. So if I do this and I click on run, as you can see, it doesn't give me any output. Even as we run it, it's just there to display. So this maybe could have been a note or something important that you need to remember as time goes by, as you look at your notebook. So you can use code, you can use Markdown. Raw NBC convert, you probably won't use this. I have personally not used it in any context, so I don't know much about it. And the next thing is heading. So heading is exactly that. It's to give you headings such that you're able to structure your notebook. If you don't structure your notebook, you're going to just be looking at cells and cells of code, and you're probably going to be very lost. So you can put some markdowns or some headings so that it's a bit more structured. So for example, this is a heading. As you can see, it's a bit, the font is a bit bigger as opposed to Markdown. So it's exactly that, it's a heading. And you can go changing the size of this heading by adding hashes. So the first one, it's bigger. When it's 2, it becomes a bit smaller. When it's 3, it becomes a bit smaller. When it's 4, so depending on the size that you would want. So for us, we can start with just the very first one because this is a very fast heading. So from here, yeah, I think that's a tour of Jupyter Notebook. There are other things that we've probably not maybe encountered, we're going to encounter as we continue doing what we're doing. So now we'll get into the coding bit of it. As I've said, the first thing that you have to learn with a programming language is the type of data that you're going to be working with, because the code that you're writing is to manipulate some data. You're not just writing code. So you need to understand, how can I store my data that in such a way that this interpreter is going to understand what I'm trying to tell it. So the very first thing we're going to do is we're going to learn is data types, and I will make that a heading so that we can start using this. So I can name this one. Let me make this heading a bit smaller so that it stands out from, yeah. So you can say data types. Yeah. So the very first data type that we're going to work with is the simplest, numbers. Let me also make that into a heading. This is level 2, so I can just keep adding the hashes until I get the side heading that I want. So here I will start with numbers. Right, so with numbers, numbers are basically, I'm sure we have encountered numbers. I don't know how to explain what numbers are, but numbers are, numbers is what is the data type that you're going to use to store your numerical information. For example, I'll try to make this a bit more interactive as opposed to just using ABCD 1, 2, 3, 4 example. So numbers, for instance, is what you would be using to store, for example, customer, maybe prices, units that you're working with, etc., etc. So numbers. The very first thing we're going to do with numbers is very simple aggregation. So for instance, the first thing we would do is probably a 1 plus 1. So what we're doing here is addition. This is addition of numbers. So it's very simple, the numbers that you would want to use, and the plus sign, which is, I'm sure we've all encountered the plus sign at some point. The spacing is not important. You can leave it as this. However, I find that spacing makes your work a bit easier and a bit neater and easier to read, so I prefer using spaces. After you've done this, you now come to run the run, and you click on it. And as you can see, it gives you an output. So this is very, very, very simple. It's likely to be, it's actually not going to be any more complicated. If you wanted to add like huge numbers, it's just the plus sign. All you need is a plus sign. There's also, okay, I'll show you that in a bit. So that is simply addition. We can go to subtraction, something very, very simple. So for instance, 10 minus 3. So this is a dot, it's a hyphen, let me call it. Be sure that you're not going to use an underscore, because this is going to give you an error. So be sure that it's a hyphen, it's a dash. After you do this, you just run. And as you can see, by default, all our cells are code. By default, any code cell is going to have this input. This is in, that is the input that has gone into the cell, and then it's going to have output, which is the output from the said cell. So this is how you know that the numbers that you, sorry, the cell that you're working with is in code. For example, if I change this cell to maybe a markdown, and I try to do to perform the same operation, as you can see, it doesn't give me any output. So you have to be very careful. You have to make sure that your cell is a code cell so that you're able to get output from it. So this is subtraction, very simple. Let's go to multiplication. Multiplication is probably, you'd probably use it when you want to find maybe like total price. You have maybe unit price and the number of units that you want. So you'd want to find out the total price at the end of it. So let's say you have 100 units of something, and the unit price is say 50 shillings. So for multiplication, we use the asterisk. I don't know if you call it a star or an asterisk, depending on where you went to school. But so for multiplication, we use the asterisk. And when you run your cell, see, you get your output. Let me, also you can make some comments within your cell so that you can remember exactly what is happening in that cell without having to read too much. For instance, I can make a comment here. Comments are made using the hash. So for instance, I can say, so that you're able to remember what the asterisk is. Maybe you might have forgotten it sometime. You can put some note right next to it. So asterisk is used for multiplication. The idea of having a comment is you're able to understand what is happening within the cell. However, the output of that cell does not contain the comment. So comments are mostly for you as the coder, as you're going through your notebook, in case you just need to write something. Maybe you've created a function and you'd want to remember what it's about later on. So when you're doing this kind of commenting, this is mostly for you. It's not for someone you might go to present this to. And if I run this cell again, as you can see, it doesn't have this bit in the output. However, you're still going to remember that the asterisk is what was used for multiplication. So yeah, then now we go to division. Division is probably, maybe you want to divide people into groups maybe. So for example, you have 12 people, you'd want to divide them. You'd want each group to have 4 people, so 12 divided by 4. What we use for division is the forward slash. Say 12 divided by 4, forward slash, okay. So, forward slash is used for division. Yeah, and then we have one last additional thing that you might probably need at some point. So we've done the very basic aggregation, but there's one last one, and this is called modulus. So modulus is what is the remainder that remains after performing the division. For instance, if I said 12, 12 divided by 5, I would get, what? Oh, sorry about that. Okay. This should be giving me a bit of a different output. Let me see if I can show you somewhere else. Okay. So modulus, this is supposed to, okay. I think because I'm using Python 2, there's a bit of a mix-up. However, I will tell you what you're supposed to do. Rather, who will want to show us on their end, because I'll just give you the instruction that you need to whatever. I'm using Python 2. That's why I was telling you have to be careful. You have to look at versions as you upgrade. For Python 2 and Python 3, there's a difference in how the division is handled. So someone who's using Python 3, anyone who would want to show us something, I'll give you all the instructions, so don't feel intimidated or anything. Okay, then I will randomly select. Let's see. The very first person who is here is Douglas. Okay. Ernest. Austin.
I'm trying to share my screen, but somebody's.
Oh, sorry. Okay, share your screen. Okay. So you can just do everything till where we've gotten to, so that at least you also catch up. I can see your notebook is blank. So you can do a simple addition. Just add any two numbers.
I can start from here.
Sorry?
I can start from.
You have to make sure that if you want to type within a cell, you have to make sure that the border around it is green. When it's blue, you're outside the cell. So click inside it. Yeah.
Okay, it's green now.
Yeah.
So
add any two numbers. And then the run. Yeah, okay. Subtraction.
2, then run.
Okay. 10, then run. Okay, then now division.
On division, eh?
Yes.
So let's do the first division, which is
first of all, do it with Okay, good. And then I'll do it with a number that is not going to give you. Okay. Yes.
So let's say 5.
Yes.
So I still run.
Yes.
Okay, giving 2.4.
This is okay. It gives me exactly what I want to show you guys. So as you can see, the output of cell number 2 is 4, and the output of cell number 4 is 10.0. So we have within numbers, we have different types of numbers. So for example, the output that is on cell 1, 2, and 3, those are integers. Those are integers. Integers are whole numbers. In that, for example, if you're trying to count the number of people, you cannot have 2.5 people, 3 3/4 people. So integers is used to store whole numbers. For example, the number of people, number of products, etc., etc. However, if you want to store something like price, you're going to have 100.9 something, something point something something. So that is going to be float. That's a float data type, and that is what you can see on cell 4 and 5. So Douglas, what I'd want you to do for me is on cell. Okay, you can actually just where it is. Kindly.
Sorry.
Let me send this. Let me send it on the chat so that it's a bit easier. So
okay.
You can do okay. Kindly type that into the cell and then run it. The type. Remember the type before the one.
Sorry.
There's the name type before the brackets. You open the brackets. Small t. Then open that bracket so that it does it. Okay, now run it. So this is what I was trying to show you. When you want to find out the type of data that you're working with, we use the command type. So as you can see, the type, when we're adding 1 + 1, the type is integer. So integer, as I've said, is what we're going to use to store whole values. You're trying to store the number of people, the number of products, such a view, whatnot and whatnot. So this is what you're going to use for integer. And then Douglas, please do the same type, but use what is on cell 5. You can do the 12 divided by 5 instead of 1 + 1.
Okay. So you say plus?
12 divided by 5.
Oh.
The same thing we've done on cell 5.
Okay.
So you can see that the type changes to float. So float is what we use for storing not whole numbers. Things, say for example, things that can afford to have a decimal place is what we use to store float. And then now I want to show you something called modulus. So Douglas, what I'd want you to do is
yes.
Let me send it to you on the chat so that it's a bit simpler.
Okay.
Where is it? Right click on the cell.
Okay. Then run.
Yes. Okay, so this is modulus. Modulus is the remainder of what happens after performing a division operation. So as you can see on cell 5, 12 divided by 5 is 2.4, meaning there is a certain remainder. However, maybe you want to divide things into equal groups, for instance, and you'd want to know if I have, maybe if it's the 12 modulus 5, you're trying to, what you're saying is, I have 12 items of something. I'd want to divide them into 5 groups. And then after I do that, how many will I remain with? So when we say 12 modulus 5, it's how many times does 5 go into 12, and then what is the remainder? So this would be important maybe if you're trying to group things and you're sure that there's going to be a remainder that remains. So you'd want to know exactly how many of these remainders have remained. So that is your modulus function. The next thing we're going to learn is something called strings. So let me convert this heading so that we are able to differentiate what we're doing. Let me make it a bit smaller. So strings. So the data type strings is what you're going to use to store. It's what strings are a combination of characters. So strings is what you're going to use to store product names, addresses, anything that can be written into a text or sentence is going to be treated as a string. So what characterizes strings is the use of quotes, say quotes such as those, or you can use the double quotes. So if you see anything that starts and ends with such quotes, that is going to be treated as a string. So whatever is within this quote, whatever you pass within this quote is not going to be modified at all. So what you put within your strings is what is going to be output. And this is where we start saying garbage in, garbage out. If you input a wrong string into it, it's going to output the same wrong string. So you have to be careful with what you put in within your string because they're not going to be modified. So we can start. So for instance, if I wanted to store my name, what I would do would be Fiona. So yeah, as you can see, I have put some quotes around my name rather. This could be anything. It could be your name, could be a product name, could be anything from this to that. So you can use your single quotes or you can use double quotes. Can use single quotes or double quotes. However, if you decide to use single quotes, you cannot go ahead and then use a double quote at the end. As you can see, if I try and run this, as you can see, it's going to give me an error. So if you're going to use single quotes, use single quotes alone. If you're going to use double quotes, use double quotes alone. You cannot use them together. As you can see on cell 9, I get an error when I try to do use both quotes in the same place. However, also if you would let me see. Let me take this to naming conventions first. So that's what you do with strings. And then now the next thing you'd want to do with strings, it's for example, let's say your string is something very long. For example, Fiona is a student. Let's assume this was a very, very, very long, sentence. So you might not want to type this every time that you need to probably use this. So what you would do is you would want to store this information somewhere such that whenever you need it is when you just go retrieve it, as opposed to having to store this information in your brain and then every time you need it, you're trying to get it from your head. So this is where we're going to get into something called variables. So let me do this to make it a bit more structured. Variables. So variables, in the simplest way that I can put it, variables are memory locations that store your data. The memory locations that store your data, such that all you have to do is remember this memory location that you're going to give it the name that you want. So you're the one to decide what you want to name it. So all you have to do is remember the name of the variable, and then it's going to tell you what data is stored there. You don't have to remember the actual data. You just need to remember the name of the variable. So for example, if I wanted to say, what can I use? Okay, let me just say sentence. I'm too lazy to type the whole thing. So let me show you. Then I will. Okay. So what I have done here, let me just show you so that it's going to make a bit more sense. Okay, so what I have done here is on cell 10, what I have done is I have told the interpreter, so there's this equal sign. This equal sign is called assignment. So what we're doing is we're telling the interpreter whatever is to the right of the equal sign, which is Fiona is a student. This would be any type of data that you want. It could be anything from this to that. It's just data that you need to use maybe later on, but you don't want to store it in your head such that you're trying to remember the actual data itself in case it's too much. You just need to remember a memory location. So this, what is to the right of the equal sign, what is here, assign it to what is to the left of the equal sign. So now when I now call send, this is the memory location of where this data has been stored. So now anytime that I need to access the data, Fiona is a student, I don't need to remember that Fiona is I don't need to remember the actual data. I just need to remember the variable in which I stored the data. So even if I wanted to use this, maybe I have like 100 cells, I would still use send without having to really worry that the data within it is Fiona is a student. It would be anything from this to that. All you need to remember is the name of the variable. So with variables, there are a few naming conventions for these variables. You won't just be able to name any memory location. You can name it anything, but there's just a few things that you have to look out for. So for instance, we have Pascal notation. So with the Pascal notation, we have, okay, so a notation is a standard way of doing things that has already been approved, such that if I was to give this code to someone else who has not sat in this class, they're not going to be wondering, what was this, what was this, what was this. So Pascal notation, every first word of the variable is going to be capitalized. For instance, if I wanted to name my variable product price, I would say product, no, let me go with product name because we're dealing with strings, product name. So you can see that this P has started with a capital letter and N has started with a capital letter. So this way you can clearly tell that these are two names, because if I say product name, it doesn't really stand out. You'd be wondering what exactly is this. So product name, this way you can already tell that there are two words here and these are the two words that are here. So we can say product name, I love sausages, so I'm just going to type sausages here. Yes, and that, sorry. And then, so when you do this, for example, what is on cell 10, this is just simply assignment. This is not going to give you any output. Whatever has happened in the background. So for you to see what has happened, you have to call the variable. Calling the variable is simply just typing out the name of the variable and hitting run. You can do this on a different cell, as we have done on cell 10 and 11, or you can do it on the same cell. For instance, here, I can just do this product name. Yeah, so you can see product name gives me the data that I have stored in it, which is sausages. Naming conventions, these are basically ways that are used, standard ways, let me not say ways, they are standard ways to name your variables, such that if you were even to give this notebook to someone who was not in this class, they would not be wondering, what is this you've named such a view, such a view. So these are standard ways to name your variables, such that you can even you can share your code, etc., etc. So the first way you can do this is using Pascal notation. So with Pascal notation, let me just make some notes right here so that it makes then. So with Pascal notation, what happens is the first letter of every word of the variable is capitalized. So, for example, I want to name my variable product name. What I will do, I have the two words product and name. So the first letter of each of these words is what I will capitalize. As you can see, product name, P is in capital and N is capital. When you write it like this, you can clearly see that these are two names. There are two names that, yeah, there are two names. It's not just one name. So that's Pascal notation. If you don't want to use Pascal notation, because you either have to either have to keep putting on your caps lock or using shift, you can use camel case notation. So with camel case notation, the first letter of the first word is not capitalized, but every subsequent word, what subsequent word? Every subsequent word. Okay, I hope this makes some sense. So with camel notation, the first letter of the first word is not capitalized, but for every consequent word, you have to capitalize the first letter. So for instance, what I have done here on cell 13, the variable name that I want to use is my product name. So you can see the M is a small letter. However, product and name each have their first letters being capitalized. This way, you can still clearly tell that there is more than one name in this variable name, and you can clearly tell that it's my product and name. So with what we're trying to do with naming conventions is you can very clearly tell what name has been given to the variable. It's not just a piece of code that you're looking at. You're able to read, your mind is able to tell that these are three different words that have been put together. So with camel notation, that's what happens. And then this is where we see that Python is very case sensitive. So as you can see on cell 13, my product name, P is capital, N is capital. If I come to cell 15 and I want to call my variable, however, I put a small p, as you can see, I get an error that is not defined because the variable that I have defined is the one that has the capital P. So you have to be very careful. If you decide to use Pascal case notation, you have to be very careful to remember which letters you've capitalized and which ones you've not. So for me, I personally prefer snake case notation. With this, you don't have to worry about capitalizing words. All your letters are in small letters, and they're just they are separated by words are separated using underscores. So as you can see, for example, on cell 16, as opposed to having my product name with my P being capital and my N being capital, I just have everything being in small letters, and then I use underscores to separate the three names. So now I'm going to show you why this was very important. We're now going to move into something we call the print function. Let me write that here. So the print function, we use the print function to modify outputs. So what we will do output print is now what you will probably be going to, maybe you're going to present this notebook to someone and you would want them to see some certain output that has been formatted in a very certain way. So print is what we use to format output. So for example, here, I can call, no, this is our one. So as you can see, my product name, it has some quotes around it because that is how we did the assignment. However, if I wanted to present this to someone, I would not like for the quotes to be around the word bread. So for me to be able to do this, I would use the function print. So for instance, I will say, so for you guys, you have to, because you're using Python 3, you have to have these brackets after your print statement. For me, I won't have to use them because I'm using Python 2. However, for you guys, make sure after your print statement, you open and close the brackets, and then whatever you want to print, we're going to put within the brackets. For me, I don't have to use them. So on your end, make sure that you do. But if I was to do this, as you can see, when I just call my variable name, it still has the quotes around the data. However, when I use my print function, as you can see, my data no longer has the quotes around it doesn't have the quotes around the data anymore. So for you guys, make sure that your print statements look like this. Make sure that your print statements has these brackets, otherwise you're going to get an error. So the other thing that you would want to do with print, so maybe you want to print a whole sentence. You might want to print it several times. However, there are a few bits of the sentences that you would want to change. For example, let's say, so let's say I wanted to print out this, let's call it statement. Let me just do this so that I'm make my points very clearly. So if I statement, first of all, I still have my quotes around my data. And in the event that I wanted to have this sentence for everyone in this, that I will have to come here and keep changing every time. However, if I don't want to do that, we can. So what we can do is we can now the variable that needs to change. For instance, what we'll be changing is maybe the name, the profession, and the age. So what we will do is we will store the name, the profession, and the age in variables such that we can be able to change those variables, place those variables within a print statement. It's able, we're going to be able to tell the variable in this place, put this variable in this place, and put this variable in this place. So let me show you how that is going to happen. Or Fiona in a variable name, I can store profession here, and I can store age here. So as you can see, anything that is a collection of characters, that is A, B, C, D, 0, 1, 2, and all the special characters, they have quotes around them. As you can see, Fiona has quotes around it, student has quotes around it. However, with age, because I'm now dealing with numbers, we don't have quotes around them. You remember even when we were doing the 1 + 1, what have you, we didn't have any quotes around the numbers. So for numbers, they don't get quotes around them. The only things that get quotes around them are strings. So I can run that. Print I open my quotation mark, this is going to be now the string that I want to be outputted. So for instance, my name is, so now what we're going to do here is, let me show you guys what we have. Okay, let me explain it. I wanted to have it as a whole statement. So what we're doing here is, my name is, we are using things that we call placeholders. Let me write all these terms here. So placeholder. This curly, we call these ones curly braces. These curly braces are what are known as placeholders. With placeholders, you're telling the print statement, please hold this space within this string that you're going to output, and within that space, I want you to output the data that is within the variable this and this. So for instance, what would go here is my name is, sorry, this would be my name and my profession is, okay, so what we've done here is we're telling this statement, my name is 1. Using the placeholder 1, we're telling it in this place, place where we have reserved this memory location. So with placeholders, what happens is it reserves a certain memory location, and then you tell it what would you want to be placed in that memory location. So for example, here we're telling it whatever is within the placeholder 1, output what is within, output the data that has been stored in name. Let me run this so that you can see it. So you can see my name is 1, and then I came, sorry, I forgot about format. So once you use the placeholders, as you can see, my name is placeholder 1, and my profession is placeholder 2. You have to use the function format so that now you're able to tell the placeholders, all right, you've already reserved this space. Now I want you to display this in that space. So what we're telling it with the function format here is, so format, whatever is in the placeholder 1, as you can see here, whatever is in 1, display what is stored in the variable name, which we declared on cell 21. And the placeholder 2, which is this, display what is in the variable profession, which we also declared on cell 21. So when I run my output, you can see my name is Fiona and my profession is student. If I wanted to add the age, I would do, and my age is, then now I give it another placeholder, so I can call this 3. And then after I've done that, I have to remember to come to the format function. If I don't, for example, if I've added the third placeholder, but I have not told it what I want to be displayed there, as you can see, it gives me an error. So for every placeholder that you create, you have to make sure that you format something into it for it to display something, because a placeholder means that it has reserved some space for you, and then it's supposed to display something. So you have to give it what it's going to display. So I will come to here and say 3 age. So as you can see now, my name is Fiona, my profession is, my age is. In the event that I wanted to change this statement, I will not have, if I wanted to say, do this for everyone who is in this class right now, I wouldn't have to come and start changing here 1 or 2 or 3 or what have you. All I'd have to do is change the actual value of the variable. For instance, Monica is the last person I've talked to, so she's the one whose name is in my mind. So for instance, I can change Monica. Okay, the rest can remain the same. That's okay. So you have, if you make any changes to a cell, you have to run it again. But the beauty about Jupyter Notebook, you can run a cell as many times as you have to. So you don't have to have so many cells giving you errors. You can just keep running the cell again and again and again until you get the output that you want. So I have run cell 25 again. That I have changed the variable name from Fiona to Monica. So if I come to cell 24 and run this, as you can see, my name is Monica. We've not had to change a lot of things. We've just had to change the name of the variable. And that's very important with your print statement, because most of the time you're going to be going through a list in your data set, or it's going to be a large data set. And if you want maybe something about each data point, you're going to have a loop. We're going to see that later. So you're going to have to keep modifying what is within your print statement. But since you can't do that yourself, you're going to be wasting so much time and energy. All you can do is just use the print statement together with the format. So that way, the only thing that you're going to have to change in the event that you're changing anything is going to be the data that is within the variable. Anyone who would want to show us? Hi, Bridget. I think that's the name, because I can see that's the name we've decided to print out. Hi.
Hi, how are you?
Fine, thank you. Your name is Bridget, correct?
Yes.
Okay. It's because your name here is a whole number. I did not know exactly who it was, but all right. Okay, you can just show us an example using the print statement.
Using the print statement.
The print and format.
Okay.
However, remember, if you're not going to use the variables on cell 22, you have to declare your variables first before you do the print.
I wanted to use something like the snake case notation.
Mm-hmm.
That's what I was going to put.
The thing is, if you're going to use snake case notation, it means that there's some variables that you have already declared. So you need to declare the variables first.
Okay.
Mm-hmm. Okay, so also with one last thing I forgot, with variables, if a name starts turning green, for instance, I can see type has turned green, that's some specific words that you're not able to use because they are specific to Python. For instance, if you remember at the beginning of the class, we did type to find out the data type that you are working with. So there's some words that are reserved. If you start typing a word and it starts turning green, that's an indication that that's a keyword for Python. So that's not a suitable variable name.
Okay.
Okay, now you can do the print statements. you have to make sure everything that is supposed to be within the string has to be in red. So you have to make sure that you close your after 0, you've already closed your quotation marks. You need to close your quotation mark at the end of the string. Everything within the string should be in red. All right. So yeah, at least, yeah, I know this is really a bit tricky to get at first, but I promise it gets easier with time. So at least with that print and format function, we're in a good place. We're going somewhere. So anyone who has a problem with this, kindly let me know.
I have a question. Is it a must for us to use those colons before the brackets?
No, it's not. Okay. You can just remove them and run it again and see the output.
Okay.
However, instead of using the colon, you can just use spaces so that the output is nicely formatted. The colons were just to make things look a bit spaced. Okay, yeah. Yeah, so you can see it doesn't matter. Whatever is within a string usually does not matter as such. So yeah, it was just about formatting. A simpler way of doing this, I had to make sure you got this first before we continued. A simpler way of doing this might have been.
Hi, Fiona.
Hi.
Sorry, I'm kind of a bit lost.
From where?
Just there, print. I don't know if I typed in something, I'm getting an error.
Okay, share your screen.
Okay.
Yeah.
So then I went to.
So 1, 2, H3 profession, and what it's telling you is name not defined.
Yeah.
Hi, Leila.
Hi.
You should run the cell the cell at the top. Yeah.
This one.
Yeah, you should run it so that you can assign the names to the variables. Yeah, and then come down.
I mean, run self.
Okay. Thank you.
Thank you for that. I had not even seen that. Thank you.
Okay.
So you can stop. Okay. So an easier way to do it would have been, however, now this requires for you to be a bit more keen. You do not have to use the placeholders. For instance, I can do that. However, now with this, you have to be very careful about the order in which you put your things within the format function. For instance, my name is, I know that they're supposed to follow each other in this order. Profession, sorry, profession, page. So as you can see with this one, I have not put the placeholders there. I've not named the placeholders, rather. I would not use the 1, 2, 3. However, with this now, you have to be very careful with how the order in which you put your things in the format statement. For example, on cell 26, even if we put 1 at the end, for instance, we put it, see on here, even if we put 1 at the end of the format statement, it still remains my name is Monica, the same order is maintained. However, if you do not name your placeholders, and I maybe change age, and I switch up maybe age and name, as you can see, my output changes. So this is when we start saying garbage in, garbage out. I have given it a garbage input, it has given me a garbage output. So if you want to use the format statement and you do not want to use placeholders, you have to be very careful about the order in which the variables are following each other in the format statement. So on cell 30, I've not had to name my placeholders. However, I have to be very careful with the order in which they are in the format statement, because what is going to happen is it's going to know that whatever is the first variable goes to the first placeholder, whatever is the second one goes to the second one, and what is in the third one goes to the third one. So you have to be very careful with the order to ensure that you get the output that you are after. So yeah, I think we're going great. One last thing. So in the event that you wanted to use 2 types of quotes in a statement, for instance, I want to say it's raining. As you can already see, there's what the interpreter has understood is I have started a string from here and it is now waiting for me to close the string. So how will I be able to print this out in the event that I want to print it and I need to do this? So you can see it becomes a bit difficult. However, if you have an apostrophe or a quote within your string, you have to ensure that you use double quotes at the beginning of the string. For example, it's, and then it is raining. So when I have used double quotes, it means that the interpreter is going to understand that because I have started my string with double quotes, it expects that my string is going to be closed with the same double quote. So even if it encounters this single quote, it's not going to give me an error and it's going to be printed out. So if you need to print a quote or an apostrophe within a print statement, you have to ensure that you start with double quotes, so that if it encounters a single quote within the string, it's not going to be interpreted as a closing quote. Okay, so we are now in for a different data type. So we have looked at numbers. Numbers is what you will use to store your numerical information. Strings, this is what you will use to store anything that is a collection of characters. Characters is A to Z, 0 to 9, and special characters. And strings, remember, have to be within quotes. I'll make those notes before I send this to you guys. We've gone through variables, we've gone through naming conventions, we've gone through the print statement. This should actually be print and format. Print and format. Sorry. So we've done print and format, and now we are in a different data type called list. So list is very similar to the lists that you know. So a list is just a collection of data. It is literally just as simple as that. It's a collection of data. It doesn't have to be data that is similar. So maybe you've gone out somewhere, you were just talking to people, you've gotten a list maybe of product names and their prices and what have you. So you'd want to store that information just as it is. So what you will use is what we call a list. So lists in Python are, I think I will make this notes here so that it makes a bit more sense. So lists are a collection of data. Another important thing, they are represented using this. We call this square bracket. So if you see some, okay, I'll show you. So for now, yes, they are represented using square brackets. So the first thing I will do is show you how to create a list. So I think we'll just create a list of the names of the people who are in class right now so that it's a bit more relatable. So I can call this my list. So with this is where we start using things like variables. I wouldn't be in a position to remember all your names severally in the event that I would have to use this several times in this notebook. So what I will do is put that data into a variable, and the only thing I have to remember is the variable. So for instance, I can name this my list. Remember your naming conventions. I personally prefer snake case notation because you don't have to worry about capitalizing and capitalizing the letters, because again, Python is case sensitive. So if you declared a variable with a capital letter and you try to call it with a small letter, you're going to get an error. So I prefer using snake case notation because you're not going to run into such errors. Right. So how to create a list? Very, very, very simple. You just use the square bracket, and then whatever you need in the to be within the list, now you put them within the square bracket. Again, a list does not hold, it doesn't have to hold the same kind of data. So remember, if you're trying to store a string, it has to have the quotes around it. If it's an integer, don't put the quotes around it. Otherwise, it's going to be treated as a string. And for instance, if you wanted to add, two numbers and you've declared them as strings, you're going to get an error because you can't add strings together. Well, not in the sense that you would think like the 1 + 1. So lists hold, I think that's also another interesting thing. So what we say about this is they hold heterogeneous data. Heterogeneous in that if you're storing numbers, it doesn't have to be just numbers, it can store numbers and strings. There are other data types that are homogeneous, that you can only store one type of data on it. So lists are preferred data type at times because they are flexible and they're able to hold different kinds of data. So, and they hold heterogeneous data. So for us, I think we'll just use strings because we're using names. So elements within a list are separated using commas. So for example, I can start with myself. Then the next element should be separated by the comma. I think let me work with names that are simply off the top of my head. Talked to Monica. Talked to Leila. Talked to Douglas. Okay, these are the names that I can remember off the top of my head that fast. So with this, you can see that the only very, very important thing is this square bracket. If you turn this bracket to a different kind of, a different data type. So remember that lists are represented using the square bracket. So if you see square brackets, know that you're working with a list. And we can see the output of this. So you can see my list is there as we have defined it. And just to show you that for sure it is a list. So we use the function type to know what kind of data type you're working with. You might have just been given maybe an Excel file, you don't even know what is in there. So you'd want to know what kind of data you're working with. What we would use is type. This is Python specific. As you move to pandas, NumPy and pandas, you might encounter something different, but is still within the same scope. So just know that if you want to know the data type of something, use the function type, and then pass what you want to know. Pass the data that you'd like to know what it is within that function. So we have type. I'm trying to find out the type of the variable, of the data within the variable, my list. And as you can see, as we have said, my list is a list. So with lists, there's a couple of things we can do with them. However, I think I would rather show you all the data types and then we come back to them, because there are a few things that are common amongst them. So for now, we've just declared lists. We'll come back to them. I will tell you that for sure. There's a lot to be done on lists, but let me introduce all the data types and then we're going to come back to that. So the next data type after lists, we have something called tuples. Depending on where you went to school, you might say it as tuples or tuples. So tuples are almost they're almost like lists. However, with lists, you'll be able to, you can add something to a list, you can remove something from a list, you can modify. However, with tuples, this is when you want to use data that you're not going to modify at any one time. So if you want to give the notebook a certain kind of data and you don't want it to be modified at all. For instance, you have maybe the list that we have created just above. However, you don't want, for example, if I wanted to come out with a list, I'll show you that later. However, with tuples, I won't be able to do that. So if you want to use data that is not going to be modified during runtime or at any one point, what we use are tuples. So tuples, yes. So another interesting thing about lists are they are immutable. They're mutable. I will show you what this means. Sorry, they are mutable. Mutable in that they can be changed even after they have been declared. For instance, on cell 32, we have declared and initialized this list. And afterwards, we can still be able to make some few changes to the list. That's what calls it mutable. So for tuples, what is interesting about this? They are represented using, now for this one, they just use the usual brackets that we use. They're represented using those. And very important, they are immutable. So I will show you how to create a tuple. Very simple. I think we can just use the same thing that we have up there. So but instead of my list, I will call this a tuple. And then remember the kind of brackets, I will actually use the same data so that you can see that the kind of brackets that you use are very important. So I can do that. And then I just copy this. Yeah, so you can see we have the exact same data. However, just by changing the type of brackets around it, we now have a different data type. Yeah, you can see from up here, when you use the square brackets, the type is a list. And here, when you use the round brackets, actually, let me just check that right here. Round brackets. Yeah. So you can see when you use the round brackets, it turns into a tuple. Again, anything else that we can do or not do with tuples, I'll show you in just a bit. Let me introduce one last data type before we go to methods and such. So the last data type that we are going to deal with today is something we call dictionaries. They're represented using, okay, let's say they store data in a key value format. Key value format similar to JSON. If you have encountered JSON, you probably know what I'm talking about. However, we're also going to see the store data in a queue and are represented curly braces. Curly braces are this one. Again, the type of brackets that you put around your data are very important because immediately you convert this type of the curly braces to a different type of brackets. You're now not going to be working with dictionaries anymore. So your brackets, the brackets you use are very important. Please keep that in mind. So for dictionaries, what we will do is we can create a very simple dictionary. We can call it my dict. So curly braces. And then now with dictionaries, it's a key value format. So for instance, if I wanted to store, say, information about myself, it would be name. Name is the key, and Fiona would be the value. So this is how a dictionary looks. There is key and value, and then they're separated by a full colon. So what is to the right of the full colon is the value, and what is to the left is the key. Please keep that in mind because it's going to make some sense why it's important in a bit. You can say age 21, and we can say profession. Sorry. Profession. Profession. Students. So I can call. So you can see the format is a bit different from what we've done before, the tuple, the list, and what have you. However, my dictionaries make your work easy. But basically, those are the data types that we're working with. Those are the data types you're likely to come across. In the event that someone hands you probably like an Excel sheet, you have different columns. Different columns are likely to be holding different data types. So these are the data types that you're likely to encounter. So for example, something like numbers, you'll encounter it with your price column. Something like strings, you'll encounter it with your names column. Dictionaries, you'll probably maybe find it with descriptions. Things like product descriptions, it's going to tell you like Bluetooth. Maybe if it's say like a phone, it's going to, if the specifications, it's probably going to have say Bluetooth as the key, and then the value is going to be the version of the Bluetooth that the phone has. So you're going to encounter these data types as you're moving along. So now I'll come back to the list. So now what I'm going to show you is methods and attributes. Methods and attributes are what we're going to use to modify our list. You might be having a list and then you maybe want to add something to it, maybe remove something from it, change something from it. Now, those are the things that we're going to use. Now, what we're going to see are the things, rather functions, methods that you use to accomplish that. So let me create some cells here. And then I name this methods and attributes. methods and attributes, yes. So first, so there's a difference between attributes and methods. Attributes are characteristics. For instance, if I was asked about my attribute, it will be a characteristic that I have. And then methods are what we are actually going to use to modify the list. Attributes are it's just information about the list as it is. So for instance, one attribute that we use is length. This is to find the length of your list. The length of a list is how many elements are within this list. For instance, if I try to find the length of my list, it will tell me how many names are within this list, and that's what we're calling elements. So how we do that is just length. Instead of the whole word, it's going to be just len, and then you pass what you would like to know the length of. So you can see that the length of my list gives me an output of 6, and that is because 2, 3, 4, 5, 6. So attributes, let me write this here. But so you can see an attribute length. Length just gives you the number of elements within a list. Simple as that. So after you have your list, you would probably now want to know how can I add something to this list? How can I remove something from it? How can I change something? So now we start. If you wanted to add something to a list, we use the method append. Let me write it up here. Append. Again, as I said, Python is very intuitive. I know if you've encountered the word append somewhere, and append simply means to add something to something else, and that is exactly what we're doing. So, for instance, if I wanted to add somebody's name to this list, what I will do is, so if I wanted to add something to this list, I would say what you want, you start with what you will want to append to, which is my list. And then we have the method append. And then within the method append, now you put what you would like to be added within that list. So for instance, if I wanted to add another name, I just have to go to participants, Abdi. So let's say I wanted to add the name Abdi to the list that we currently have. Okay, so and then after you've performed an operation, you now have to call the list again so that you can see the changes that have been made to it. So as you can see, Abdi has been appended twice because I have run this cell 2 times. So any time that you run a cell that has the method append on it, it's going to do exactly that. So let me show you again. I can run my list again so that we only have it once. Yes, you can see now we only have one. So my list.append, my list is what we would like to add something to. Append is the method, and what we would like to add to the end of this list is the element Abdi, and here it is. So we have append. Append specifically adds it to the end of the list. In the event that you wanted to, add it to a different position of the list, you would use something else. So now here we come into something else that is very important. Python is a zero index language. What a zero index language means is anytime you're counting something, especially positions, you're going to be starting from 0 and not 1. For example, in my list, I have 6 elements, as we have seen, using the attribute length. I have 6 elements. What I would do sorry about that. What I will do is I start counting the number of elements starting from 0. So Fiona is at position 0. Ernest is at position 1, Eric is at position 2, Monica 3, continuously. Again, let me show you this before we continue because I know it might be a bit tricky. So something else that we'll see just a bit later, but let me introduce it here, is what we call slicing and selecting. So slicing and selecting is about trying to get a certain bit of your list or a tuple or a dictionary. You're trying to get a section of it as opposed to all of it. So this is also where we also say Python is a zero index language. You start counting from 0. And with slicing and selecting, we also use the square bracket, but it's not going to be interpreted as a list, and I'm going to show you how. So for instance, if I did this, what I'm telling it to do is, please show me what is at position 0. Remember, Python is a zero index language. So if I ask it for what is at position 0, it means I'm asking it what is the very first element in my list. So what has happened here, this is what we call selecting. You'll encounter this with some time, don't worry. So with selecting, you're now trying to get a certain element from the list as opposed with working with the list as a whole. So with my list square bracket 0, I'm telling it, kindly tell me, kindly show me what is at the element that is at index position 0. So we start counting from 0, and this is from left headed right, just the way you usually write. So the very first element is at index position 0. The next one is at index position 1. So what we are passing here is the index position, and we start at 0. So whatever is at index position 0 is the first element in our list. So if I wanted to add an element to this list, but not at the end of the list, what I will do is use another method called insert. So what I will do is use insert, and then I will pass the position that I want to add this new element in. So we know Fiona is at position 0, Ernest is at position 1, etc., etc., etc. So let's say I wanted to add, can add my second name right after my first one. So I would want to insert this new element at position 1 so that it comes after what is at position 0. So I will say insert it at position 1, and what I want to be inserted is that. So I'll have to call my list again. So as you can see, I have Kamau right next to Fiona, and it is at position 1. So again, Python is a zero index language, and with this, especially with lists, tuples, dictionaries, yes, they are ordered. They are ordered in that they hold a specific position, and that from one of them you can move to the next, and from there you can move to the next, to the next. So with Python, it's a zero index language. So whenever you start counting such index things, you start counting from position 0 as opposed to 1. So in our list, we saw that Fiona is at position 0, etc., 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 etc. Then with if we wanted to add something to our list that we already created, you can use the method. There's 2 ways you can do it. You can use append. However, append adds it to the end of the list. So if you do not want to add this new element to the end of the list by default, you can decide at what position you would want to insert it into. And with that, you are going to use insert as opposed to append. And remember, the positions, we start counting from 0. The first element within your list, your tuple, your dictionary, is always at position 0, not at position 1. I know that might have been a lot to take in, so someone show us something on a list. You don't even have to bother about tuples and dictionaries for now. Just show us something in a list. If it's not clear, also just tell me to repeat it again, and then I'll choose someone.
Okay. Hi, Fiona.
Hi.
Sorry,
Someone.
I realized I ran hello.
Yes.
I realized I ran I realized I ran something twice, and that Kamau name appeared twice.
Okay, just share your screen.
Okay. Yeah, I ran this twice, and
Yeah.
it appeared Kamau twice.
Yeah, exactly that. Every time that you run that cell, it's going to perform that operation. So what you can do is, where you first declared my list, the very first cell where you created my list, the very first one, run it again. Because what happens is, after you've already run the cell twice, the one that has appended it twice, you are actually changing the list exactly as it is. So what you'd have to do is go back to position 0. You have to go back to the drawing board, then start again. So run the cell that you ran first that has my list, and then run that append or insert again. It should be just once. Still waiting for someone to share their screen and show us something.
Okay, let me just try. I know it's a bit confusing, but let me just try.
It's okay. The only way you're able to get it is actually doing it.
Yeah, okay. So
Thank you for that.
Okay, so
Right. So don't even worry about tuples and dictionaries, just go to list.
Yeah, so I'm going to create a list here, which I want to declare for now. So maybe I'm going to.
Also, one thing.
Yes.
If you do this, my list, if you also name it my list just as you named the first one, it's going to overwrite the first one. So if you don't want to overwrite the first my list, give it a different.
Okay.
Yeah, that's okay.
Okay, so then I'm going to have elements in my list.
Your list in
sorry.
square brackets.
Sorry?
Square brackets. The square brackets.
Yeah. Yes. Then I have. Okay. Then I need to run. Sorry.
You guys are getting these things fixed, all right?
Then I run it.
My list 2. Make sure it's going to give you a
sorry.
Yeah.
Okay. Now, for example, if I want to add an element, I'll have to go to my list 2, then do append. And is it the normal bracket or?
The normal brackets, the round ones.
Yes, so the normal bracket where I'm going to be writing maybe Augustine.
Yeah.
Then I run it. Sorry, I have to write my list here. Then I run it. Then I'm able to have that. So what is the other one? To maybe add with a certain, to add an element with a position.
A position, yes.
Yes, so insert. Then I will add, let's say Mike. Sorry.
You have to give it the position. So
yeah, we have like, okay, so if I want that, then it's
before you run it, Where
Yeah.
do you expect Mike to show up before you run it?
After Fiona.
Right. Okay.
Yeah. So once I run it, then yep.
Yeah. So now you probably want to remove something from a list. What the method that we're going to use for that is called pop. So what happens with pop? Let me just show you what's going to happen so that you're able to see. So by default, what pop does, pop is the cousin to append. Pop removes the last element in the list by default. So you don't even have to pass anything within pop. If by default you want to remove the last element in the list, it's going to do that for you. And what it shows, the output that it shows is the element that it has removed so that you know what has been removed from your list. So if we look at my list now, you can see my list no longer has Abdi on it. So you can also pass a position within pop so that you're able to remove an element at a certain position if you don't want to remove the one that is at the end by default. So for instance, we can say my list, pop. So we can remove Kamau because I can see that it's here twice now. So what I will do is count the positions again. Python is a zero index language, so we start counting from 0. So Fiona is at 0, Kamau is 1 and 2. So I can remove the one that is at position 2. So if I say my list pop 2, it tells me what it has removed. But also if I check my list now, you can see I only have 1 Kamau. So with pop, if you don't pass a position within it, it's going to by default remove the very last element in your list. However, if you don't want to remove the last element in your list, you just have to count. You just have to pass the position that the element you want to remove you pass it within the pop method. So we have now added something to our list. We have removed something from our list. Also, you can, if you don't want to use pop, you can also use a method called remove. Again, Python is very intuitive. Append, that's add something. Insert is to add something at a certain position. Remove is to remove something. Pop is to. It's very intuitive. If you just sit and listen to the functions, you'll probably just be able to already tell I need to use this to get this done. It's not so difficult. Python is intuitive. If this was Java or C++, we'd be having a whole situation, but Python is among the simplest programming languages, so this shouldn't be an issue at all. So if you're going to use remove, with remove, you now have to give it the exact element that you want to remove. So for instance, we can completely remove Kamau from the list. And if I look at my list now, yeah, you can see with remove, you can see Kamau is gone. So the 3 ways to remove something from a list is you can either pop. Pop is going to remove the very last element in your list by default. However, if you don't want to remove the last element in your list, you can pass the position of the element you want to be removed to the pop function. If you don't want to use the pop function, you can also use remove. However, with remove, you have to be sure of the exact name of the element. That is the only drawback. So I personally prefer using pop because I don't have to type exactly what is in there. I might not even know what is there, but I know the position that it holds. So I would highly advise using pop as opposed to remove. So these things that we're able to do to the list, that we're able to add something, remove something, this is what we mean by the list is mutable. With tuples, as we're going to see, tuples are immutable in that once you've already declared this list, I won't be able to add, I can't be able to add Kamau, I won't be able to change Fiona to anything else. I can't add Abdi to the end of this, to the end of that tuple. So if you're working with data that you don't want to be messed around with, declare it as a tuple. However, if you know you're going to be working around with your data, use list. So that is what we mean by list are mutable, in that you can change things, you can change the list even after you have already declared it, like you have here on self. So the other thing you'd want to do with a list, you added, you've removed. So the other thing you'd want to do now is be able to change change the position, change the value of a certain element within our list. So again, here we're going to come back to a bit of selecting. So how to change the value of an element is, you tell the compiler, I want this element that is at this position, and then you give it what you want it to change to. So how we're going to do that is, to choose the element, what we are calling selecting, is what we've just done, is the square bracket 0. So for instance, if I say 0, my list square bracket 0, this is selecting. I'm telling the interpreter, give me the element, rather it's choosing the element that is at position 0 in my list. So what is at position 0 in my list is Fiona. So at this point, I have selected it. And then I'm telling it, okay, so whatever is there, now give it this value. And this value, I can change it to Kamau. So if I look at my list now, yeah, you can see that Fiona has changed to Kamau. So you select the element that you want to be changed. This could be 0, 1, 2, 3, 4 till the end of the list. So 0, 1, 2, 3, 4, 5. So say if I said position 5, I want you guys to be able to very clearly see this. You can see position 5 is Douglas. I won't run this. I'll just put it here. Sorry. Yes. 0. Okay. So that is how you would change something, the value of something in your list. Again, this is what shows that a list is mutable. With tuples, you won't be able to do this. So yeah, that's what we call mutability of lists. So someone kindly just show us how to use pop and how to change the value of something, and we're going to be done with lists for now. Not clear on pop. Okay. Mukundi, just share your screen. I show you what it is, and then you can show us an example, then we can move. All right. So, just scroll up a bit so that I can see everything. Okay, so that is it. All right. So with pop, you have appended. Wow, you've done it a couple of times. Okay, what I would advise is kindly run cell 46 again. Okay, then run cell 75. Yeah, so you can see at least it's just done it once, so that you're just dealing with a few things here and there. You can scroll down until now where pop is. Okay, so my please run cell 73 again so that we know what my list looks like. Okay, so pop. So pop is used to remove certain elements from a list. If you don't pass anything within pop, by default, it's going to remove the very last element in your list. So for example, remove the 12 within pop. on cell 79, you can remove the 12, run it. Okay, so now run cell 77 again so that you can see what my list looks like after the pop. So you can see that Mulisa is gone. What is happening on cell 83 is it's telling you the element that has been removed. So when you look at now my list as it is, when you call the variable, you can see that Mulisa is no longer there. However, if you wanted to remove, say, David, now you would have to pass the position of David within the pop function. So you can add a cell after my list on cell 84. You can go to cell 84, or okay, yeah, that's okay. So my list, the same thing, my list dot pop. So if you wanted to remove, okay, you can decide which name you want to remove. However, now you have to count the positions. And remember, Python is a zero index language. So John is at position 0, Sarah is at position 1, etc., 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 etc. Seven. Okay, so you can now run my list again so that you can see if that name has been removed. No, the one on cell 84. So yeah, you can see the name is gone. Again, what you do on Jupyter Notebook is sequential. So if you have run cell 83, you have to make sure that whatever is on cell 84, if it depends on cell 83, you have to make sure that you've run cell 83 before you can do cell 84. Please be careful about that. Sequential, Jupyter Notebook is sequential. But I hope the pop is clear.
Yes, it is. Thanks.
Okay. You can also show us how to change the value of an element.
Change the value of an element.
Okay. We'll just do it with you. So you can, on cell 86, you can add another cell before or after it, whichever is okay. So you can go to either that plus or the insert, so that you can decide if you want to insert it on top or below, but this is fine. So to change the value of an element, you first select the element that you would like to change. And with the selection, it's using the square brackets and the index position. So what element would you like to change? Which name would you like to change to something else?
Wanjiru.
Wanjiru. Okay. So Wanjiru, as you can see, is at position 2, correct? Because John is at position 0, Sarah is at position 1, Wanjiru is at position 2. So yes, finish typing my list. And then selecting is done using the same square brackets that I used for list. So put the square brackets. And then now pass position 2. Just the number 2. Yeah. So when we've done this, we have selected the element 10. And then now what we're going to do is put an equal sign after the bracket is closed. No, after the bracket is closed. Yes. And then now you give it the value that you will want to change it to. You want to change it to whatever you want to change it to. If you want to do, if you remember, if it's a string, it has to be within quotes. Okay, so you can run that. And then you can call my list so that you can see what has happened. So yeah, you can see that 10 has changed to 4. So that is how you change the value of an element in a list. You select the element, and the selection is using the my list square bracket, and then you pass the position of the element that you would want to change, pass the equal sign, and then what you would want to change the element to. I hope that is clear now.
Yes.
All right. So guys, unless there is any questions on list, I think that is where okay. So guys, I hope you've had an informative class. I've tried to make things as simple as they could be. If you have any questions, kindly reach out to me on the group at any time. I'm going to send this notebook to you in a bit, along with the presentation. There's a quiz that is supposed to be done. I don't know if you'll be able to attempt it with the bit of knowledge we've learned today, but we're going to try. So the quiz is going to be given to you guys. I'm going to send you all these materials. If you have any questions, feel free to ask. Don't worry about anything. And unless there is anything more to be said, I think I will see you guys next week.